Okay, so we're going to go through the standard approach to dealing with a lot of these issues, and that is to come up with preferences for risk and reward. You've probably seen this diagram in your introductory finance class. I'll review it fairly briefly, but ask questions if you are not completely sure. The basic idea here is that we're going to start by asserting that investors have preferences over different characteristics. And the basic assumptions are that you prefer more to less, that you have diminishing marginal returns. The more of something that you have, the less excited you are about the incremental value. And transitivity, if I like X more than Y and I like Y more than Z, then I should be able to have that transitive relationship, X is preferred to Z. That may not always be true in practice because people are people and we're all fickle. But for the most part, we do seem to adhere to these basic assumptions. And so when you're taking a look at the various different rank orderings of bundles, certain bundles cannot be easily compared. For example, I can't tell you whether or not everybody would prefer A1, B1 to A3, B3. But I can tell you that everyone would prefer A2, B2 to A1, B1. How do I know that? What axioms am I using, Mikhail?
You get in more A's and more B's.
Exactly. More is preferred to less, so I know that you're being made better off in both dimensions of A and B, so that's got to be true. Unless, of course, I've lied to you, and these are like toxic waste as opposed to goods. But by definition, a good is something that's good versus a bad, which is something that's bad. So if they're goods, then yes, everybody would prefer A2, B2 to A1, B1. Everybody would prefer A2, B2 to A3, B3 for the same reason, right? A3, B3 has the same amount of B, but less of A. So because more is preferred to less, there's a pretty clear rank ordering. But between A1 and B1 and A3 and B3, who knows? Because it depends on how you trade off A versus B. So there is no easy way for us to tell whether or not investors would prefer one versus the other. So the basic idea then is to try to come up with a method for rank ordering these various different opportunities based on the characteristics. And so the two characteristics that we're going to look at, one is a good, the other is a bad. So the good is on the vertical axis, the expected return. The higher the expected return, the more excited you are, the happier you are, the greater your utility level. And on the horizontal axis, that's going to be measured standard deviation of the asset. The larger it is, the worse off you are. You don't like risk. You want to reduce the risk. So in this case, it's pretty clear that General Motors is going to be an asset that you would prefer or not prefer to Merck. What would you say? Can you tell? Yeah, not so clear, because remember, the horizontal axis is a bad, not a good. So are you unilaterally better off with, say, Motorola versus General Motors? Motorola is this up here. What would you say? Yeah, of course. Because, or no? Yes or no?
It's not clear. The standard
Right.
deviation is larger for Motorola, but the expected return is also larger.
Exactly. It is not clear. In that case, it's not clear. It looks like it should be because of the previous diagram, but remember, as I said, the horizontal axis is a bad. So in this case, Motorola has more risk and more expected return, so it's not clear. It's got something that's better than that everybody prefers, but something that everybody doesn't prefer. So you can't easily rank order it. What about Merck versus McDonald's? So this is McDonald's down here. This is Merck up here. Yeah, exactly. There, it's pretty clear that everybody would prefer Merck to McDonald's. The direction where it's unambiguous that we are all better off is if we go northwest in this diagram, right? Northwest, Seattle is the place you want to be, I guess. This is the direction of nirvana. High risk, high return, low risk. That's what you are looking for. So in these kinds of pairwise orderings, You can actually say something unambiguous about McDonald's versus Motorola. Clearly, they have the same risk, but Motorola has slightly higher expected return. Everybody prefers Motorola over McDonald's. Everybody prefers Merck over McDonald's, but General Motors versus Motorola, who knows? That depends on you. So when you think about it from the perspective of picking one of these investments, it's not that easy, because you can do certain kinds of pairwise comparisons, but in general, there's no obvious answer. So ultimately, what we're left with is, let's find the individual's preference curves and try to go as northwest as possible, given what they can afford in terms of their budget constraints. And that's how you decide what to recommend. So if you had to pick one stock overall for this particular individual, it would be Merck. Higher utility is going to be farther northwest. But on the other hand, if you're talking about a somewhat different individual, you can easily see that that ordering may be different if they have different risk preferences. So the basic idea behind portfolio theory is to try to come up with a quantitative way of making these kinds of decisions about how to allocate your investments across these various different assets. And for life sciences portfolios, they're no different. The challenge will be quantifying these parameters. Before we get there, let me go through the basic properties of portfolios now and talk about how we're going to go about it. And in a way, this could be viewed as a derivation of the CAPM, but I think that using the CAPM for capital budgeting doesn't require you know anything about the derivations. But now we're going to focus on specifically how to use these ideas for portfolio theory. So the idea behind portfolio theory is, let's construct a good portfolio. By good, I mean one that's got a good expected rate of return and one that's got a good volatility of return. In the diagram from the previous slide, I want to go as northwest as possible. Let's construct a portfolio that's as northwest as we can get it so that we can make our investors happy. So in order to do that, I need to write down the expression for the expected return of the portfolio as well as the standard deviation of the portfolio. This is the expected return. Nothing surprising here. Simple weighted average of the expected returns of the individual components of my portfolio.